This video is part 2 of branch attachments. I recommend you either watch or review part 1 before you continue because the details are really important and we're not going to go over them. In part 1, I covered the branch collar as well as the branch bark ridge, which are external features that indicate where the branch and the stem meet. They're not obvious in all trees. Sometimes it's because of the species and sometimes it's because of the size of the branch relative to the stem. When the branch is large relative to the size of the stem, it's harder for the stem to wrap wood around the base of the branch, especially when they're this close in size or they have a more vertical attachment. The xylem of this stem and this branch are basically running in parallel, and so there's not a lot of overlap in this middle section here. Might just be a few annual rings worth of growth. And if you don't have as much overlap, then you're not going to have as much swelling and the branch collar won't be as apparent. And in a situation like this, because you only have a smaller overlap of wood in this area, it's going to take less force to tear this branch off compared to having something much smaller that's got a nicer angle and that's embedded deeper in the parent stem. There is a name for the ratio between the size of the branch and the parent stem that it's attached to. It's called the branch aspect ratio. Let's say we have a 1-inch diameter branch and the parent stem is 5 inches. 1 divided by 5 is 0.2 or 20%. If your branch is about half the size of the parent stem, it's 0.5 or 50%. And in a situation where your branch and your stem are basically the same size, you have 100% branch aspect ratio. These are very similar in size. Let's call that a 1-to-1. You would call these codominant stems or double leaders. The branch aspect ratio is the #1 indicator of the strength of the branch attachment. You want to have an aspect ratio of 50% or less to have a strongly attached branch. Another important factor is the angle of attachment. You can imagine a sharp or narrow angle as a V. You can also have vertical branches that have more of a U-shaped union, and these are stronger because there's space in between here for natural bark formation. When you have a narrow attachment, both stems are growing vertically and will be equally vigorous, and they'll often end up being similar in size to one another. Narrow or acutely angled attachments are also more likely to have included bark in the center, which we'll cover more later. In part 1, I covered the branch protection zone. It's located at the base of a branch in the branch collar, and it produces chemicals that seal off a branch when it's damaged. It prevents whatever problems the branch has from getting into the rest of the tree. The formation of that branch collar and the branch protection zone are both linked to the size of the branch. They form best when the branch aspect ratio is 50%, meaning it's at least half the size of the parent stem or less. When it's larger, there's less or no formation. Now we're going to talk about included bark. On branches with a narrow angle of attachment, the bark of both the parent stem and the branch can get trapped in the middle, and both the branch and the stem are going to continue expanding in size and thickness. There's pressure that gets pushed on the bark and the cambium that's trapped in the middle, and they can die, which can lead to decay inside the attachment. The bark itself also acts as a barrier that blocks the wood of the branch and the parent stem from joining and overlapping one another. So when you have included bark inside an attachment, the whole attachment might just be held together by a few years of wood on either side of the attachment, which makes it pretty weak. When you approach a tree with a narrow branch attachment, look at the outside. If there's a furrow or a seam, one that's rolling inward or sunken, you likely have included bark. Just make sure you're not confusing it with the branch bark ridge, which is going to be in the same area, but the bark is raised, and that's normal. As the stem and the branch move independently of one another, that can create cracking inside the little bit of wood on either side of the attachment. What trees do when they experience stress is to add more wood to those stressed areas to strengthen it and to reduce the amount of movement that occurs. That results in pronounced bulges on either side of the crack, which I've heard casually referred to as elephant ears. The larger the bulges, the more compromised the attachment because it's constantly feeling the stress that the tree is trying to fix with more and more wood. When you run into situations where you have poor branch attachments, you can look at either removing one of the branches entirely, or in situations where perhaps it's too late for you to cut off the entire branch, you could look at subduing part of the branch so that it's no longer as vigorous and competing with the main leader. Over time, because the leader will be growing more vigorously, it's going to get larger than the branch, and the branch aspect ratio will rebalance closer to that 50% that you want.